This tutorial provides the solution to problem number 29 in the final review. In this problem, we are given a tank with a pipe attached to the tank at 20 meters below the surface, and there's a pump along that pipe. What's given to us that there is a flow of 8 cubic meters per second through this pipe, and of course this discharge is coming from both due to this elevation, as well as the pump is adding pressure to this flow. And it is given that the head loss over this pipe is related to the velocity, which is 7 times v squared over 2g. So the question is, how much power is supplied by the pump to this flow? And of course, we know that if we know the head added by the pump, we can determine the power. So first of all, we'll find out how much is the head added by the pump, and then based on that, we will determine how much power is added by the pump. So first of all, we need to find out how much is the velocity of flow through the system. So discharge is given to us, and we know that the diameter of the pipe is 1 meter. So we can find the velocity using Q over A formula, which gives us a velocity of 10.2 meters per second. So now we will apply the energy equation between section 1 and section 2 to find out the head added by the pump. And of course, we know that along this pipe there is head loss HL, and let's say H1 is the starting head and H2 is the ending head. Then from the energy equation, we know that these are related. We know that H1, which is the total head at section 1, must be equal to the head at section 2 plus any losses along the way, plus any losses due to the shaft. Now again, if this was a turbine, this would be a loss. If it is a pump, it will be a gain, and in case of pump, HS will be a negative number. So this should work out fine at the end. So all we have to do is plug in the corresponding values of the total head at section 1 and section 2, which is all the heads at the section 1 is equal to all the heads at section 2 plus head loss plus shaft head. Okay. So we know that both of these ends are exposed to atmosphere, so we can easily note that P1 is going to be equal to 0 and P2 is going to be equal to 0. Now on the section 1, we know that it's a stationary level, so the velocity at section 1 is equal to 0. From the diagram, we know that Z1 is equal to 40 and Z2 is equal to 20. And we already calculated the velocity through the pipe, which is actually V2. So we can now simplify this equation to find out what HS will be. So HS will be 40 minus 20, and then of course these two terms are to be added, so this will give us minus 8 times V2 squared over 2G. And we already calculated the velocity that we can plug into this, and you will find through calculation that the head, because of the pump, is minus 22.4 meters. And of course, the minus sign indicates that this is a gain into the head instead of HL, which is positive, which is a loss. So negative sign means this head is added to the flow by the pump. And of course, when you are using this value, you will not be using the negative sign. So to find out the power that was added by the pump, we know that the shaft power is given by gamma QHS, and we can plug in those values. Since this is water and this charge is 8, we can write this as 110 newtons per cubic meter times 8 times 22.4, and this gives you 1.76 into 10 to the power 6 watts, which is same as 1.76 megawatts.